We are going to talk about generative adversarial networks. So basically this is the neural network where we are having a generator and an discriminator. So generators are used to generate the images and discriminators are used to tell that if the generated image is quite correct or not. So this is the basic idea of a generative adversarial network. Here I have given a document as well where it's clearly given that a generator learns to create an image that looks real, while a discriminator learns to tell real image apart from the fake. And this process goes on up until the image does not look similar. So this competition between generator and discriminator to tell the images and generate the images creates a real looking images which are not really real, but it looks like yes they are real. So this is the process, like MNIST dataset we are given over here. So this is the dataset and generators are generating, and discriminators will tell that yes if it's correct or not. If it's not correct, then the images will again be generated with the another firstly this is all will be noises, and then it will go to here, then loss we generated, and the loss generation then going back to the generator with the same losses and then updating the loss. If you know about the neural networks how it works, so you know all these things. So this is what the basic idea of generative adversarial networks is. Here I will not talk more about these things about the definitions, but yes, this is what it is. And if you want to learn more, you'll be having some blogs on the Wikipedia where you can learn more and more about that, and there are various videos as well where you can learn more about the generative adversarial networks. And this is a good approach to, this is a good area to learn, because this is basically like teaching our child to learn the things. So telling a child that yes this is a train, so 10 times he will say train, then the child will get to know yes this is the train, my father has told me or my brother has told me or whoever. So the child will learn, the next time it will see, then it will be like yes this is train. But if you want to tell the good thing about the discriminator, and which is not good in the humans, we get tired. So if you want to say like you tell a child that this is an coconut maybe, so 10 times you say, 12 times, 30 times, and if the child is not getting, then after some time he'll be like okay I don't want to learn if this is a coconut or not, I don't even care. But computers are not like that. The more you will say that yes this is the coconut, this is the coconut, they will more learn and they are better at the predictions. So here like I have used the TensorFlow version 2.5.0, and it's my recommendation to go for a collab only, because collabs are good. And if you are having a higher GPU powers, then yes of course you can go for that, but for minimum GPU powers you should go for the collabs, because collabs are giving you much of a 12 GB RAM for non premium membership, and those who are premium are getting 25 GB of RAM. So yes, this is all the libraries which will be used, and this is where the data is being downloaded from the MNIST dataset. This is the dataset. It's, if you are in the machine learning field, you already know about the MNIST, what it is and how it is. So this is what the dataset looks like. Here I have subplotted it. I'll not talk about this because if you are on the generative adversarial network, so I believe that you know much of the things about these all things, like how to code and all. So just like clearly show you that how it is done and where it is different from the other things. And here data set is like what's the size of data sets, and here we have created a generator model over here. So if you see, then it is the same as the neural network, and it is this is the return model is like, yeah, you know the Python, like you can return a if you are creating a method, then you are supposed to return whatever you want to print or not, or whatever you want to do. So this is the return methods, like it will return a model over here. So here the generator model is having my is 7 into 7 into 256. This is the input size, and bias I have not used anything. Input step is 100, and first like 100, and then I don't care whatever it is, but the 100 should be there. It is how it is. And so yeah, this is the generator layer. And if you see, then we have created with the help of generator, we have created a random noise. So it could be anything, we don't know where it is, what it is, so it is random, and we have just plotted it to show that what the random noise looks like. And if you want, you can take the help from the collaboratory, or if you are in the Jupyter notebook as well, you can get the help, but you know what I mean. Yeah. Then this is the discriminator layer, where discriminators are like telling you that yes, if it's the correct not, like as I previously told that the use of discriminator layer is that it will tell you that if it's the similar to the image or not. It have to decide like yes, if I'm getting correct or not, or is there any issues with that or not. So now you, with the help of discriminator method, you can take the help. It's the same, like you can type the question mark and you can get the help from the Google Colab. So binary cross entropy is used as a error losses to define the losses. The discriminator loss. So real loss is the like what's the difference between a real loss and the fake loss is that the you see that this method qualifies how well the discriminator is able to distinguish the images. So like suppose that 1 is the real image and 0 is our fake image. So the zeros will increase and try to reach to 1. So as soon as it reaches 1, then yes, it knows that yes, this is the correct image. So you're getting my point here. So 0 is like there is no difference found, but as it will increase, then we have to decrease the losses, difference between the losses, real and fake losses. And here is the generator loss. Cross entropy is used, and Adam optimizer is used. This was like error from me, like I had used triple P and I was like, why it is not getting the correct output. This is of no use over here, it is used afterwards. So checkpoint directory is like in the same I have used. If you see, where is that directory? So yeah, so these are all the images like I have run. So these are all the images over here. It is always recommended to use the checkpoints, because this will take more time to run. So if you are not creating a checkpoints, then maybe chances are that you have lost what you have written so far, so it's of no use. So always create a checkpoint over here. Then yeah, so here is the training. And so yeah, this was the thing which I was checking over here. So here I had written triple P. So it took me some time to what's the error over here. I was all over the internet. So yes, so this is what the generator images is generating with the help of noise. Training is equal to true over here. So their training was, if you see, it was false because we are not training over there. So yeah, training is equal to false because we are not training over here. But here it have to true because we are training over here. And real images, fake images. So generator loss, these are all the functions which I created above only, which I have told you as well. Now here we are training on the data sets. Like we are not training, we have just created a train which will take a data set and the number of epochs you want to train. Now here we will be just generating and saving the images, like which images are generated and being saved over here. Here I am training the model. So here the model is being trained. I have trained for like 60 epochs. Yes, 60 epochs. So I have trained for 60 epochs. And so save a Jupyter notebook before going to starting the next cell. It is as I have showed, create a checkpoint. Here I have not restored it. Oh, so why have I written it twice? I don't know, maybe I should delete one. Yeah, so this is the display images. So this is the last images which I have got. So you can train for more times and it will go like, yes, you have got something like more. The more you train, the better you will get. This is the thing, and this is of no use. Like if you want to save the images, this will go get it on whatever, wherever you want. So this is to download the images, and if you see, then this is the images, and in the end, if you see last epochs, if I open this, it will open. Yeah, so it's opening. So this is the last epoch, and this is if you see the first epoch. So or the second epoch only. So see the difference. In the second epoch you can't even tell that if it's one or not, but in the 60th epoch it is quite a bit. Like yes, 6, 3, 9, 8, still it's don't know what it is, 9, 8. So if you train for more epochs, you will get more, like if it's correct or not. So this is what the generative adversarial network is, and thank you for watching. And if you have any doubt about this, please do comment and I will try to solve the issue.